Getting on the road. Well,
It's not that bad.
thank you so much. We need one more if we're good. Sorry, yeah.
Thank you.
Right. So, okay, so I handed in a bunch of paper. First thing is we'll go over the homework. So what I've done is one of them, the homework 3, hw3.text, is simply the printout of the homework. I'm going to go through it on the screen, but I don't know. I think it's sometimes easier to look at on the paper if it's hard to see it on the screen, if you wanted to write notes on it or whatever. Okay. I'm done justifying why to make copies of that. So, I guess on Monday you watched the video and saw this extension of this idea of having loops within loops. In this case, we have these two. You learn that you can put, for good reasons, nest one loop in another. To start off with, I feel a little bad I wasn't here on Monday. Is there any question on that? No one emailed me, or I guess as you did the homework, hopefully that reinforced it, or it became clear as how it works and why you would want to use it. So in this particular case, the homework called for you to print out all the ranks and suits first of printing out all the ranks for the suit. So you're printing out the 2 of hearts, the 2 of diamonds, the 2 of spades, and then you're going on to the 3 of hearts, the 3 of diamonds, and the 3 of spades. And whenever you want to have things repeated, you're going to use some sort of loop. Of course, we could have used a while loop instead of a for, but hopefully you saw that the for made it much easier. There wasn't really that much to do, assuming you set this up this way. And so again, the way this is going to work is after we assign these 2 lists, the for is going to come in here, and we're going to create a variable called rank, and we're going to initialize it to the first element in the list ranks, which is going to be hearts. And strike that, it's going to be 2, and then we then fall into the for loop for suit, and we're going to now create a variable called suit, and we're going to initialize it to the first value in the list suits, which is going to be hearts. So now rank is equal to 2, and suit is equal to hearts, and so we're going to print out 2 of hearts. And now this print statement is really really the statement that gets executed in this inner for loop. So we go back to the suit for loop and now take the second element from the suits list, which is going to be diamonds. And now suit is going to be diamonds. Rank doesn't change, okay? We don't really fall out of this for loop yet because the statement that gets executed, there's actually really 2 statements executed for the rank for loop. It's actually the statements associated with the suit for loop and then the word print. And so we're going to go through this and iterate through this 4 times for each element of the suits. So we're going to do 2 of diamonds, 2 of hearts, 2 of diamonds, 2 of spades, 2 of clubs. And then when you have finished all the elements in suits, you now come out of there and you now execute print, which is part of the outer for loop, the rank for loop. So we simply print a blank line. This simply prints nothing. And now we go back and now we go up and get the next element from rank, which is now going to be 3. There's still more elements in rank, so we get 3. And then the critical part is now we fall into the rank loop and we restart the suits loop, now initializing suit to be equal to hearts and going through that 4 times. Heart concept, incredibly powerful because we can now generate, we can do multiple things. The outer loop is controlling the rank and the inner loop is controlling the suits, and with really 4 lines of code, we were able to generate a ton of functionality. So, any questions? Did you guys get this? Okay. Chris?
What would have happened? So I got it right, but I pretty much got it right by accident. What would have happened if you reversed suits and ranks, like in terms of which is inner and which is outer?
Okay, so when I run this, let's just be clear, right? It went through all 2s, all 3s, all 4s, right? So Chris, this first runs once, and then this runs 4 times because there are 4 suits. After it runs the 4th time, it prints a blank line and now gets the second element of rank, and it runs this 4 times again.
Okay.
So you're going to answer the question. What would happen if I would have reversed the suits and the rank?
It would have done it would have done like parts once, and it would have done the ranks like
It would have been,
all the ranks.
right, it would have been 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 6 of hearts. It would have done all the hearts,
Yeah.
stop, and then it did 2 of diamonds, 3 of diamonds.
Yeah.
Get it? Okay, any other question on that? Okay, next batter is, so here we're going to, so this problem was to, that we're looking to calculate what an investment's going to be over a period of time at 3 different interest rates, 3%, 4%, and 5%. and we start with a balance of 1,000, and we want to see after 5 years, well, we want to see what the value is going to be each year going up to 5 years. So here again, this calls for a nested for loop. The top loop is going to control the 3 different interest rates, 3%, 4%, 5%, and then the inner loop is going to print out what the value is going to be each year. Right? So that calls out to be 2 different loops, one to control the interest rate and the other one to control the years. And so I had here that my rate, so I have this variable called rate that I'm setting equal to 3 through 6. Well, actually, it's 3 through 5, right? Because it stops one before the ending value. And now I'm going to print out the interest rate, and now I'm going to set the balance equal to 100, and now I've got to convert my variable rate into a decimal number. So I simply take the rate and divide it by 100 to get a decimal number. And now that I've got my interest rate in decimal form, now I'm going to set up another for loop that's going to go through the 5 years that I want to see what my investment's going to be. And so I'm going to set a for loop with a variable year, iterating 5 times. And now I'm going to calculate what the balance is, take the balance, multiply it. So I'm actually calculating, I'm doing annual compounding. I'm taking the value, multiplying times the interest rate, adding it. So this is telling me how much money I'm making this year based upon interest, adding it back to the value, and putting it back into the value, printing it out, rounding it, and come back. And so this is going to calculate, this is going to run through 5 times, calculating the balance. And then when I fall out of this, after I've done this 5 times, again, I print a blank line. And now I go back to my outer rate loop, which is now going to change rate from 3 to 4. 4 is less than 6, and so I'm going to come in here and redo this again. And note that because I'm falling into the for loop, I restart the for loop. Year will be initialized to 1. You might think, well, you were in the for loop before, it's going to pick up where it left off. No, because I came into the for loop, I didn't come back iterating through it. I came in from a line above it. It's going to reinitialize the variable year to 1 and do it all over again, which is exactly what I want it to do. Any questions or other ways of doing this? Thomas?
I had put the rates as kind of as a variable in the beginning, like the brackets, 103, 104, 105.
Very good. So you had, let's see, you had rates.
The same strategy as we used kind of for column 1. So I put like rate equals the bracket, and then I said like for element in rate, and then that's how I kind of, instead of using rate.
Like this.
Mm-hmm.
And then if you did that, you didn't have to do this calculate. You could have just used rates here. You didn't even have
Exactly,
to.
yeah.
Right. That's very good. That's good. Okay. So see what Panos did this. He said, let's create a list of the different interest rates and make them in decimal form. And then he is going to iterate through. He doesn't have to. You'd have to multiply here by 100 to get the percentage.
Exactly.
So this is fine. I guess I like mine a little better. Right. I'm not trying to be petty here. I easily could do that. Because if you wanted to expand this, you would have to do more typing. My way, you would simply have to So what I had before So in this particular, I said, well, here this is doing the interest rates from 3% to 5%. And I said, what would it be to 9%? All I'd have to do here is to change this to 10. You'd have to do a little more typing. So it's a little more, I guess, general that way. Yours has the advantage, though, I guess I'll take that back. Yours has the advantage. Mine, because the values here can only be integer values. I wouldn't have, what if you would have said, you could have come back to me and say, oh, fine, but yours couldn't do 3.5%. And yours could have, because you would have put in 0.035.
The
So
only reason I did it was because for number one, it was like the
it
same.
was a pattern, you did it that way. Yeah, I'm good. Okay. Any other questions on that or any other comments? Well, if you got this one right, then the last one was really straightforward, because all you were doing in the last one was taking the basic framework of this problem. All the code is really the same, and the only thing that you're doing here, so this code is really the same, and the only thing that you're really doing is instead of having a hard-coded value for the starting balance of 1,000, you prompt the user for 1,000, and you're putting a starting rate and an ending rate, and instead of what I had between 3 and 5 or 3 and 6, I'm simply using the variables there, and instead of having 1 to 5 years, we have 1 to n years. And note I have to add 1 to n years because of the way the range statement works. This is going to go 1 up to, but not including. If I just had n years there, it would do 1 year less. And so my alternative is to either take the number of years and add 1 to it, or I could have the same thing, because all I want to do is this number of times. I could have done 0 to n years. That would have been equivalent. Otherwise, all I was doing is making you prompt for the values as opposed to hard coding the values in. Okay. Any other questions? Otherwise, I'm moving on. Once, twice, 3. Okay. So we're going on to a new topic, and let me say as a preface here, I'm going to introduce this idea. My suspicion is the bulk of you guys are going to say, okay, I sort of get it, but why do I need this headache? That might be a takeaway after going through half of all of this lecture. That would be reasonable. You'll just have to have faith that this is an important idea that will be of value to you later. It will be a little bit of a headache to you now. But if you're going to do any sort of programming in the future, you need to have this idea. Okay, so that's my disclaimer from the beginning. Otherwise, you just have to learn the crap anyway, because it's going to be on the exam. But it's an important idea. So whatever gets you through this lecture, you can use either motivation. Okay, ready? This is not, you gotta listen. We, in writing Python code, we have taken advantage of the fact that built into Python are a bunch of functions that Python has provided for us to make our lives easier, because it does things that we need to write our programs. So, for example, in dealing with strings, it was of value to us to be able to have a function which counted the number of characters in a string so that we can then do some stuff. And so Python created for us this function called len, which we can call, and it will provide us the number of characters in a string, right? And we learned a bunch of other functions, right? And we take advantage of those functions in writing our code. It makes our lives easier in writing code that somebody else took care of the headache of writing code that counts the number of characters in a string. We could have done that if we wanted to, but it was so much nicer just to call a function and it returns that value. So everybody should agree that functions, the functions that Python provides, makes our life easier. And if somebody wrote it once in the world, from sort of a societal point of view, why can't everybody share it and simply use it subsequently? And that's what happens in programming language. Somebody who wrote Python wrote the length function, and everybody in the world who uses Python can now use the length function. It's a great thing. It turns out, okay, if you buy into the fact that I can very easily get functionality by just calling a function, what sometimes happens, though, is when I'm writing more complicated programs, there's something that I want to do, and in fact, I might want to do it multiple times in my program. The same action, you could have used the length function multiple times. But let's suppose a situation occurs where there's some function, some calculation I want to do in my program, and I want to do it multiple times. Right now, you'd have to repeat that code multiple times each time you'd want to get that calculation. Wouldn't it be great if instead anybody who knows Python, could write their own function? So what I'm going to talk about today is this very, very important idea of allowing us as programmers to create our own functions. In all likelihood, these are just functions that we will be using within the program that we're writing. It's not typical that we're going to write a function and then publish it and everybody in the world is going to use it. It's possible. Python's open source, and so we could add to the Python source code and other people could use it. I'm not worried about that now. What I'm worried about is us being able to address the issue of being able to do a calculation or some function multiple times without us having to repeat that code multiple times. And that's what a function is. So what we're going to learn today is how to create our own functions. So let me go back to the motivation. So I'll come back to that. So what I handed out, I'm going to put it on the screen. So there's something with, so just the other page I gave you is just the homework assignment, and I normally hand that out. So everything I handed out has two sides. At the top it said solution without function, solution with function. So let's just turn to the one that has the solution without function. So my problem here is, so here's the code that I've written. Here's the problem. If you look at this, this is a problem where we did something similar for homework where we're prompting the user, we want to compute GPA, and so we're going to get a number of courses, so we have some variables counter and some credits and some grade points, and we initialize that, and we prompt the user for the number of courses. Stop me if you're not following me. You should again be on the page with the heading solution without function. And then after we prompt the user for the number of courses, we do some use of while loop to do validation, to check to make sure that the number of courses is greater than 0. That's what that while loop does. And then after we know that we have a valid number of courses, then we're going to put in a for loop. We're going to now prompt, we're going to go through and get the grade that the student got, and then the number of credits, and then we're going to calculate the GPA. So we have a for loop that we're going to go through for each of the number of courses. That's this. And the first thing I want to do, everybody, is I want to now put out a statement which is going to now prompt the user for the numeric grade. I want to give them instructions to say, okay, if the person got an A, then put in a 4. If the person got an A minus, put in a 3.66. If the person got a B plus, put in 3.33. So I have these 5 print statements that's giving the user information about what they have to type in for the grade. And then they enter the grade, and then what I want to do is I want to validate that the grade that they type in was valid. In this case, I'm just making sure that my validation test is simply saying that it has to be greater than 0 and it has to be less than 4. So this is my validation test here to make sure that at least the number is between 0 and 4. It's not beyond that. Okay? Now let's suppose that they violate that, they type in a wrong value. What I want to do is print out an error message. And then I want to print out that prompt again to tell them this is what you should have been entering. So here's the key, guys, in terms of me motivating this. You'll notice that this prompt here, these 5 lines here in the validation loop are the same 5 lines here when we first came in and prompted the user. And because of the way I set up my loop, I have to print out that statement twice. I've repeated that same those 5 lines of code twice, once here before I get into the validation loop and a second time in the validation loop, right? But it's doing the exact same thing. All it's doing is it's printing out those 5 lines. Why did I have to print it in twice? Wouldn't it have been great if instead of having to type those 5 lines twice, I could have written a function which prints out the 5 lines. And each time that I wanted to use to print out those 5 lines, I simply call the function. This is a very simple case of why you would want to use a function, and we're going to start off small so you understand the mechanics of it. But does everybody see that if I had to do it again, I hate typing, I would prefer not having to type in these same 5 lines of code twice and just type it in once, and then be able to get those 5 lines of code to be able to run whatever I want. The rest of the program is the same, okay. So now I've convinced myself that this is a good idea to be able to not have to type it in twice. So now what I'll use, okay, Professor Rosenthal, okay, I bought into this is a great idea, fine. I swallowed the bait. How do I create a function and how to do this? So here's what you got to watch. So we're now going to change the way we write Python programs. So whatever class we're up to, whenever we typed in a Python program, we just started off and typed in the line, and the line's got to execute one right after the other, right, when you type in your Python code. Start at the top, go down to the bottom. And that obviously works fine, but I will tell you that as you write bigger programs, you can't use that methodology. I mean, it will work, you could type it in, but if you write in a 200-line program and you're simply going from the top to the bottom, it's going to be difficult for you to keep everything in check to make sure that it's working properly. And so we're going to change the structure in which the way we write Python code. It's basically going to be the same with the following differences. We're now going to be incorporating functions every time now, from now on. Every homework you're going to submit from now on, unless I say otherwise, is going to be using functions. You're going to be creating functions to do your homework. And now this code is going to change as follows. And on the back of the page, I'll show is how this thing changes to use this with functions. My intent here is to now not having to repeat these 5 print statements. And so the deal is, I'll take out this line and see if I can do this from scratch. No. I make a mistake. Okay, so everybody watch. I'm going to go through this a couple of times. So my intent is to extract out of my code those lines that print and incorporate them into a function. Number 1, if I want to define a function, the command or the statement within Python to create a function is you have the letters DEF, short for definition. And then after the letters DEF, you have the name of the function. You can give the function any name you like. It follows the same rules as creating a variable. Don't create a function name. I don't think you can. Don't have a function name that's the same as one of your variables. So to create a function, you have the letters DEF, a function name, an open parentheses and a closed parentheses, and then a colon. That tells Python that I want to create a function called gradeinfo. After I have the definition of the function name, I then have indented all the statements that I want to have executed in the function. And here are the 5 statements that I had before. And again, I've printed this out for you. It's on the back. It's on the back of the page. It says solution with functions. And I can send you the code if you want. I think it's important to try to understand it. You can write notes on the piece of paper. That's sort of why I gave it out. So I've now changed my Python program to now incorporate I've defined a new function, a function called gradeinfo. And after the definition of the function, I now put in whatever regular Python lines that I like. While loops, for loops, variables, if statements. There's no restriction on what gets executed within a function. In this case, it was a rather simple function. All it's doing is it's printing stuff out. So we've now seen the mechanics of defining a function, which is quite simple. It's the letters DEF, space, function name, open paren, closed paren, and a colon. Now, when I write programs, everybody, I can have as many functions as I like. And so if I wanted to create a second function, which I do, and which you guys will always want to do, here I've created a second function called main. DEF space main, open paren, closed paren, and colon. I've created a second function called main. And you'll notice in main now, that really has the bulk of the code that I had before when I didn't use the functions. I'm initializing my variables. I'm prompting for the number of courses and doing validation. I'm having my for loop to get the number of courses to go through for each course. And now, everybody, here's the kicker. If you recall, if you look in the solution, in my other solution where I didn't use functions, at this point I print out my print statements. This is the old solution. Now, in my new solution, now that I've created a function, now if I want to print out all those statements, instead of having all those print statements, everybody watch, I now say gradeinfo, the name of the function, open paren, close paren. By having gradeinfo there, what Python now does when it executes this code is it says, oh, he wants to execute a function called gradeinfo. It's not one of my functions, mine being, I'm talking like Python. It's not one of my Python functions. It must be one of their functions. Oh, he did define it up here. And so when this code runs, it's running, it's going down one statement at a time, and when it sees gradeinfo, it says, well, A, did he define gradeinfo? Yes, he did, or she. And then it now stops execution at this point, and now resumes execution up here. And now it executes this statement, and then this statement, and this statement, all the statements in gradeinfo. And once it has completed executing all the statements within gradeinfo, it then returns back to the next statement after where gradeinfo appeared and resumes the program there. So the gradeinfo, the call to gradeinfo, the statement, this is how I execute gradeinfo. I simply type the name of the function, open paren, close paren. When that happens, grade info, this program now suspends execute, this code suspends its execution, and now we start executing code here. And this all completes once it gets to the end, and now we come back to to the next statement after grade info, and it continues ongoing. And so now I do this calculation, blah, 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 and now I want to run grade info again, and so I simply call it again. So I can incorporate in this other function called main, calls to grade info as many times as I want. So here is, I'm making use of calling this code multiple times without having to type it. All I had to do was type it in once. Surya?
I understand why we define grade info. What's the point of defining main?
Okay. Let me go through. Okay, so let me go through what you're going to do. I'm being dictatorial, as in you will do this. Then I'll say why you should do it, and then we can explore if you didn't do it, what would happen. So I will answer your question, not quite now. But first things first, you guys got the mechanics down. We've defined a function. That's how we defined it. This is how you get it to run. Simply type in the name. And you could call it from wherever you want. I'm calling it twice here in this main program. Nick?
The part in I guess the grade where you have counter added, is that just a shortcut from just what we usually do? Like when you have it like inside of the input? Where it has like SPR counter?
I'm not sure where I'm looking.
Oh,
Over here?
Precursors, yes.
Yeah, this. Yeah. Let me go back to that. It is a short. The problem is I can't put counter. When we have print statements, Nick, we can simply have strings and variables interspersed. The input statement's different. I can't have a number here. I have to have a string.
I was just wondering what the purpose of putting that there was.
It's simply, so it's going to take what counter is. So counter is a variable that's going to go from, so I'm simply forming the string enter the grade for a course. When this runs, it's going to say enter the grade for a course, and this is going to be 1, 2, 3, 4, 5. Okay, last point, we're going to go through this again. Okay, so here is the kicker. So we've created this function called grade info. As Surya pointed out, we've created this function called main, and he's not real happy with why I created a function called main. Notice here, go to the bottom. Let's go to the end. So after I have all the statements that are associated with main, and they're all indented, they have to be indented, you'll note that the last line of the program has the word main, open paren, close paren. So what does that mean? Okay, so Surya, when you see main, open paren, close paren, what is that going to cause Python to do?
Run that entire function.
What function? It is going to run main. So the deal is here, everybody, okay, just watch. When I type this in and I have defined grade info, Python, when it executes this code, when I click F5 to run this thing, Python's not going to do anything with grade info from the get-go, because the only time grade info is ever going to get executed is if some other part of the program calls grade info. Otherwise, it's ignored. What about main? Well, main is a function. So this code here that's associated with main, that code would get ignored until somebody invokes main. And how do you invoke main? You invoke main by typing in main, open paren, close paren. So after we type all this in, when Python looks at this, what it sees is two functions, main and grade info. It says, okay, that's nice. I'm not doing anything with it yet. And then it's looking for something that's not in a function, because that's what it really wants to execute. What does it see? It sees the only thing that's not incorporated in a function is the call to a function called main. So when Python looks at all the stuff that we've written, it says, I'm ignoring, okay, I see he's defined these functions, that's very nice. The only thing he really wants to run now is this thing called main. And so it sees the call to a function called main. It says, oh, I know it's now I need to do something. I need to run the function main. And so it goes up here and it says, oh, he's got a function here called main, and it's got a whole bunch of statements here. I'll run that stuff. And it's going to run all this code because we call the function main. And in this function called main, we see that we call a function called grade_info. And Python's okay with that. It says, fine, I'm running the function main, and within the function main, he wants to call this function called grade_info. Fine, I'll run grade_info. So my point is that when you type this stuff in and you have these defines of functions, they only get executed once they're called. The only thing that's ever really run is something that's not in a function. And so from now on, everybody, okay, here's the dictatorial part. Every program you write now, unless I say otherwise, will consist of at least two things. The last line will always have main, and you always call you could have called this whatever you wanted, but the standard is within the industry is you call the main thing you want to run main. So the last statement in all your homeworks and every code you write will be main open paren close paren, and you will now have a function called main where you're going to have all the top level code where you're doing stuff. So if you were doing the homework, for today, and if you were to listen to this lecture, no, that's the wrong one. Right. So how would this homework would have looked if you would have handed this in for Monday? You would have had the following. You would have taken this code and you would have put this in a function called main, because everything you're going to be writing now will have at least a function called main. And so this is the same code that I have had before, but now I've simply incorporated that, I've added that, I've created a function called main, and now the last statement calls main. So now, instead of this code executing, first starting with assigning suits and then ranks and whatever, blah, 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 the way this is going to work now is the first thing that Python executes is a call to the function called main. Then control is passed back up to here, and now I'm executing all the statements here that I had before in the one program. Everybody get it? If you don't, I have to do it again. You have to get this. It seems stupid. You're saying, why? You're not getting any different functionality out of this. Why are you going through all this, creating main and creating this function? And this is the faith-based part of today's lecture. You just have to buy in that this is going to make things ultimately easier for you to write. Yep.
You don't have to put like print main or anything, it just prints it automatically.
You don't have to say print. You simply, Panos, all you need to do is when it sees, this is what you have. You have a function called main here, right? Mm-hmm. Here you have a call to the function called main.
So it'll go up and execute it after it's here.
Correct. So the sequence when Python is actually executing this program now, where before it would have executed this statement first and this statement second, now it executes this statement first, and now it goes and says, oh, he wants to now execute the function here, this statement second, because this is the first statement within main. Got it? If I wanted to, I could have called this XYZ. There's nothing magical in main. It's just a convention that people use for writing code. So we always run our main function first, and we call it main. But Python could care less what it's called. I got to get everybody to say, I understand the mechanics of it. This is what you would have done for homework if if you would have handed this in for Monday. This is all the, otherwise, all this other stuff is exactly the same. You're just putting this within, you're putting this within the, within at least one function. I'm not, did I answer your question, Surya? Sort of?
I think so.
You're going to restate, give me the question again.
Well, my main question was why, I understood like why we're defining, what is it called?
Get grade, grade info? Yep.
What I was having trouble understanding what's the point of doing mean, but I guess the way I see it is if you're writing chunks of code, I think it's easier to kind of just block it out.
Okay, that's 100% right. Okay. So everybody, hopefully, here's where I think you should be at. Everybody understands the mechanics of how this works, what I got to do. There's not that much you have to do to get to use functions. Everybody should understand that. If you don't, raise your hand, I'll do it again. Don't be bashful. Okay. Everybody gets that. The next legitimate question would be, I don't see what it buys me. You've just put in a statement here, and now I've got to understand, I can put this main at the bottom. It seems like you've added additional things that I have to remember to program, which I'm not sure how I get an advantage out of that. All the other stuff that I've showed you before with lists and the for loop and the while loop, you should say, yeah, I see why that is important because it gives me this ability to do this sort of computation, to write a program to do this. But this, what the hell does it buy me? Okay, and it's hard for me to motivate this, but you got to believe it's true. I'll give you two motivations. The first motivation, which I'm going to hammer home to you, which you should get ultimately when we do more complicated programs, is the following. I'm going to give you harder programs to write, and it's going to be composed of problems with subproblems. As you look at this code, as you look at the problem and try to come up with a solution, your mindset should be, I see there's this subproblem that has to be solved within this bigger problem. What I should be thinking of is saying, you know what, why don't I write a function that solves that subproblem? Simply say, I'm just going to isolate that one subproblem and put the solution of that in a function. And then when I want to now execute it, I simply call that function. So it provides for me a way, when I'm writing my code and attacking a problem, to very simply segment this problem into subproblems. And then what happens is once I've done that segmentation, and I actually haven't solved that subproblem yet, but I know I need to, I can then just isolate and think about, okay, now I'm just going to solve this subproblem. In the case that I gave you before, it was simple. It was simply printing out the 5 print statements. But I didn't have to worry about that when I'm trying to attack the overall problem. So it gives me a way of very simply to compartmentalize these different things that I have to solve. And then once I've solved each one of those things in isolation, I can run them by simply typing in the name of the function.
So if you have two separate, I guess, functions, and you have to have them coordinate with each other, wouldn't it kind of be difficult to have to, I guess, spell it out to run one and then the other? If you had it without, it would just run at once.
But, okay, let me give you the second motivation, which I think answers your problem. So let's get out of the classroom and go to the real world. And suppose, what do we got in your class today? Suppose I got a dozen, so suppose of us are a programming team. Everybody here is a programming team. And we're writing a big project. We're writing this program that is going to solve this particular problem. It's big. No one person could write it. So how are we going to come up with this solution? How is our team going to come up with this solution? Well, the way we'd come up with a solution is I would say, Nick, okay, there's this one section, here's this one area of this problem that we need to solve. You're doing that. Okay, there's this other problem, part of the problem, that Surya is going to solve. Another problem Panos is going to solve, right? So everybody here takes a part of it. And then somebody's going to say, okay, we're going to put these things all together. And so that partitions into saying Nick is going to write a function that's going to provide this particular functionality. Or Nick might, in solving what he needs to do, he might write 6 functions that does that, and there's this one other one that you call to get all the other ones 6 to run. So in terms of your answer and coordinating things, let's just suppose I've made myself king here, and I'm the person that's calling everybody else. So in the coordination, I'm writing this and say, okay, at this point, I've got to call Nick's portion. And then after Nick's portion, I'm going to call Surya's portion. And it could be that based upon what Surya's portion returns, I might have to call your portion again. So all I'm doing effectively, just like I'm pointing my finger, instead of pointing my finger, I write instead grade info. This would be Nick. And if I wanted to call Surya, it would be Surya. And if it were Panos, it would be Panos. Get it?
Yeah.
So that's the beauty of it. I simply, okay, and real life, let's go to Microsoft, let's go to Facebook, let's go to any company. That's what happens. Because the problems are too enormous to write for one person, and so you need to break it down into chunks. The other possible benefit, Nick, is we write this product, we make $1 gazillion, and now we want to make $2 gazillion. And we have another idea another programming idea. And let's just say the second programming idea is different, but some of the stuff that we wrote would be applicable. Well, then I could take the code, suppose yours was. I could take that code and put it into this new project. And I don't have to reinvent it. And from a company's point of view, look how much money I've saved. Right? It's equivalent to General Motors building a car. Right? And so this model, so they have this car, they have a 2019 model year car, right? And it's got a powertrain in it. And they've designed this, the engineers have come up with this power. Now we've come up with a new design. But it turns out I want to use the same powertrain. I simply use the design for the 2019 powertrain, and I design other stuff and incorporate it. The exact same idea. For us, the value is not going to be, we're not doing a team project here where people are doing different parts. For us, the value is going to be in breaking down the problem into smaller parts and then being able to call it. Okay? In the beginning, it's going to be tedious for you guys, and some people are going to rebel and say, oh, this is just not buying me anything. It was much easier when I could just write the code from top to bottom. Okay, I get it. You got to resist that. Okay, so I'm posting the slides. A lot of what I said and the hand waving are written more formally here. I think our best shot at understanding, going back and reinforcing the mechanics of this is to everybody now do the following problem. We're going to write a program in class now that is going to do the following. We're going to write a program that consists of 4 functions. One function, which I'll give you, which you're going to call hello, is going to print out the string hello from the hello function. Okay? And why don't we start small? So everybody now, in the next 5 minutes, I'm amending this. We're going to go through this step by step. I want you to write now a program. It's a very simple program. It's going to be 6 or 7 lines that is simply going to print out the word hello from the hello function. But you're not going to simply, obviously, you could have said now, left to your own devices, okay, you would have simply said print hello from the hello function. And if I would have run that, obviously it would give me what I want. But you're now right, so that works, right? Hello from the hello function. But what I want now is instead of just having this one line of code that gets executed, you're now going to write this as I said from now on, that you're going to now, well, actually not, you're going to now have a function that is going to now execute this. So you're going to have a function that's going to execute this. So write a program that calls a function that's going to print this out. Okay? So you're now just going to exercise the mechanics of using functions. And if you get confused, look at the handout where the grading, the solution I had with the functions in it to. Okay. So I said we have to create a function called hello that prints this out. So the way we create this function is we say def and then the name of the function hello, open paren, close paren, and then we have indented the statement we want to execute. So that defines the function hello, and that function hello prints out hello from the hello function. How would I get this to execute? Panos? So this would actually work. Okay, everybody. So if I did this, I now have hello, it's not indented. This is not what I want, but you're right. That's a good answer. And now if I run this, it prints hello from the hello function, because what gets executed is the Python says, oh, this is a statement within, this is a statement it executed. It's not part of a function. It's not part of a function, so it says, oh, he's calling a function. So it calls hello, prints out hello. So the order would be this gets executed, then it comes up to here, then this gets executed. The hello function completes, and then it goes to the statement after the call to hello. There's nothing there, and that's the end of the story. However, but I do want from now on that we're always going to have a main function. So I don't want to call hello. That did work, Panos, you're right. What I want to do is the last statement in every file is going to be main. And Chris, what's going to be the statement in main that I execute?
Hello.
Right. So now I've defined two functions, main and hello, and now it comes down, Python sees this, it says, I'm not doing anything with this yet, it's not called, it's just defined. I see this is defined, I'm not running it yet. Now it comes to main, which is always going to be the last statement in my file. It says execute main, it comes up here, it says, oh, here's my main function. It says, oh, main function, I want to call hello, it calls hello, it comes up here, executes hello, this is what it does. It returns from hello, it comes back to main here, there's no more in main, it comes back to the call to main, there's no more in main, and that's the end of the story. Chris?
What if you define hello within the definition for main? Still before you call for it, but it's within the definition.
You mean this?
Yes.
You can't define a function in a function. The functions are separate.
Couldn't you look at main as almost like a table of contents you put at the end? I don't know if that's a good analogy, but where you just kind of execute all the different.
That's very good. So let's go through this. That's good, because this is what's going to happen. Everybody get this? You're going to answer your own question, because your answer is yes. So now let's go to the next part. I want you now to incorporate a second function called goodbye. So after you print hello from the hello function, okay, I want you to say that's all, folks. But I want goodbye to be a function. So I want, now that we have this framework, I want you to now add a new function called goodbye. And you're going to say, I want your program to say hello from the hello function, and I want to say that's all, folks, and the program to end. So add that to your code. Okay? So what do I have to add to this to get goodbye in there? Well, I've got to define a function. And it doesn't make any difference where I put it. So I'm going to call it goodbye. And I want to print out, that's all, folks. That's all I want from goodbye. So that defines the function goodbye, but it doesn't call it. Now where do I want to call goodbye?
Right under hello.
So now Python says, okay, I see we're going to run main. I come up here, I run main. First thing main wants to do is call the function hello. I then go up to hello and run this statement for hello. It exits. Notice it hasn't done anything with goodbye yet. It comes back here, and then it goes to the statement after hello, and it turns out the statement after hello is the call to goodbye. So I go up to the goodbye function. I execute it. After I execute it, I come back to goodbye. There's nothing after goodbye. I've already executed main. There's nothing after main. End of story. Finally, okay, everybody get it? Let's do now the last two parts. So I want to write a function called body, which prints out this is the body line. And then in main, I want to prompt the user for the number of times to run the body function. So the behavior is going to be, so the behavior I want is first prompt the user for the number of times to run the body line. Then I want to print out hello. Then I want to print out the body line for as many times as the person wants to print out this is the body. And then I want to print out that's all, folks. So, get it? So the way this would look is, and so that you would print that out, I would say 3, and then it would say the output would be hello from the hello function. And then it would say this is the body. This is the body, because I said 3 times. This is the body. And then it would say that's all, folks. That's the functionality I want. So this is the prompt. I said 3, and this is what it would print out since I said do the body 3 times. Okay, so the first thing is we want to define this body function, so we'll call it body. Print this is the body. Now, I haven't called it yet, and I need to prompt to know how many times to run it. So, sort of as Nick said in terms of a table of contents, in main, notice I've called hello and goodbye. In main now, I'm going to now say num is equal to int input how many times to run body. Right? So that's my normal input statement. I'm going to put that into num. Let's just assume it's legitimate. So now I know how many times to run body. I'm going to print hello. I want to print goodbye at the end. So now I want to run body. Now I want to print for as many times as they said the body program. So I know I'm going to call body. But I want to run that for num times. So what I need to do now, how would I get this to run a number of times?
I use the for loop.
In what?
I said in range 0 to none.
Great. So Chris used our regular for function to, I created a variable count. It could be anything that I simply wanted to run 0 to num times. It's going to run it 3. If I were to type in 3, that's going to run it 3 times. And now it's going to call body 3 times. So the main function really is this sort of higher level thing that gets some information and calls everybody else. In this particular case, it called body. It did the thing for calling body 3 times, or however many times what num was. And note here that I have the call, 3 different calls: the call to hello, the call to body, and the call to goodbye. So again, the way this would work is main would get called, main would run, it would prompt and set num equal to whatever the person responded to. Hello would get called, hello would run, it would execute this statement, it would exit out of hello, it comes to the statement after this, now this it would come to the for loop. So count would be set equal to 1, I call the body function, it calls body, I print out this is the body, the first call to body exits, I come back, I now increment count, count's less than num. I call body a second time. I call body a third time, assuming num was 3. On the 4th time, this is going to fall out of the for loop. I then go to my goodbye function. I call goodbye. I exit this statement. I then come to the statement after goodbye. There aren't any more. I fall out of the main function and now come back to where main was called and execute the statement after main. There isn't any. There never will be. And that's the end of the program. So going forward, everybody, straight. Any questions on this? Really, I get it. Everybody should understand the flow of how this thing gets called and where control is passed to and what statements are executed in what order. At the very least, everybody, from now on, the last line of everybody's program is going to be main, open paren, close paren. And if you didn't want to create any other functions, you're still going to create a function called main, and in main it's going to be all the stuff that you do to solve the problem. I'm saying going forward, it's more likely than not in main, when you solve the problem, you're going to say main should be calling one or more other functions, and they would simply be defined in the same way. Okay? Okay, well, that's it for today. There'll be the homework assignment, of course, will exercise using functions. You get more in terms of the mechanics of it. I will go over this more to give more motivation and more practice in terms of doing it. It is an important skill to have, so. Okay, everybody have a good weekend.